As if we haven't discussed enough of calculating depreciation expense, we are going to conclude with a fourth method allowed by GAAP, which is called the sum of the year's digits method. So the sum of the year's digits method is probably the most strange method. We determine our depreciation rate based on some fraction. And here you see the fraction shown here, which is the sum of the number of the years in the asset's estimated useful life. Let's work our example. Let's put some notes down and then continue our example using the sum of the year's digits method. So this method uses a declining depreciation rate on a constant depreciation base. And remember, depreciation base or depreciable base is equal to cost minus salvage value, the net cost to the company of that asset. So the sum of the year's digits method should look somewhat similar to the double declining balance method, right? The double declining balance method uses a constant rate on a declining depreciation base. So the book value, declining book value, was a changing depreciable base. And now what we have is a declining depreciation rate on a constant depreciation base. But both of these methods, double declining balance and sum of year's digits methods, both of these methods result in a lot of depreciation taken earlier on in the asset's life and less depreciation taken on in the later portion of the asset's life. So our depreciation expense in sum of year's digits method is equal to the number of years remaining in the asset's life divided by the fraction that we saw earlier in the slides, which is called the sum of the year's digits. And that takes a little bit of explaining. So this whole term gives us our depreciation rate that will change over time because of the number of years remaining in the asset's life is going to change and decrease over time. This is the depreciation rate, and we're multiplying this rate by the depreciation base, cost minus salvage. Okay, so we still haven't defined what is the sum of the year's digits. Well, if we have a 5-year asset, as we do in this example here, we have a 5-year crane. The sum of the year's digits would be like this: 5 years plus the 4 that are remaining, plus the 3 after that, plus 2 after that, plus 1 after that. So in other words, 5 factorial. And this works out to be 15. So the sum of the year's digits in our example, an asset with a 5-year life, estimated useful life, gives us a sum of the year's digits of 15. Now you're probably thinking, what if this was a 20-year crane or an 80-year crane? Would we have to sit here and solve the factorial for however long it took us? There's a formula that we could use if we have a really high number of years and we don't want to just add the factorials together. We take n, which n is the number of years in the asset's estimated useful life, times n plus 1 divided by 2. So where n equals the estimated useful life in years. Okay, so let's see that in this example we have 5 times 5 plus 1, which is 6, divided by 2. So 30 divided by 2 gives us sum of the year's digits of 15. Okay, so now that we know that, we still have to actually solve for the depreciation expense, accumulated depreciation, and book value in each year. So I'm going to start with, like I did above, start with my depreciation rate in each one of the years. Remember this, in this example, depreciation rate will change each year because the sum of the number of years remaining in the asset's life will change. Multiply that rate times some depreciation base or depreciable base, and that gives us depreciation expense. Okay, so the rate is a fraction, number of the years remaining. So when we first buy the asset, we have 5 years remaining, and divide that by 15. So 5/15 is the rate in year 1. The depreciation base, well, that's going to be the same always. Remember, this is a constant depreciation base. So 5/15 of 450,000, this works out to be a depreciation expense of 150,000. And let's also solve for accumulated depreciation in each year and ending book value in each year, at the end of each year. Okay, so what is the depreciation rate in year 2? The numerator is how many years are remaining in the asset's life. 4, because we're also always including the year that we're taking the depreciation expense for. 4 divided by, and then it would be our n factorial, which is 15, the sum of the year's digits, 15. So 4/15 of the constant depreciable base, 450,000, gives us depreciation expense of 120,000. In year 3, we have, of course, 3/15 times 450,000. In year 4, we have 2 years remaining out of the denominator of 15, so 2/15 times 450,000 gives us depreciation expense of 60,000. And an ending book value at the end of year 4 of 80,000. And in that last year, we have 1/15 left times 450,000. This gives us depreciation expense in year 5 of 30,000. Accumulated depreciation of exactly what we want, 450,000, and a book value of exactly what we want, salvage value of 50,000. And now we have covered all of our 4 methods of depreciation expense. The next set of videos is going to talk about what do we do when we buy our asset, not on January 1st, where we're taking an entire year's worth every year, but what if we buy our asset midway through the year? How do we adjust our depreciation expense for partial